I work at Square on the Cash app, and today we're going to be talking about SQL, specifically like SQLite, and embracing SQL without abstraction. If you're familiar with Square, then you probably think this is something that we've been doing since we started doing persistence on Android, but that's actually not the full story. We have like a really storied, I guess, journey through persistence where we hit like multiple levels of abstraction on SQL. And instead of just sort of selling our SQL products or telling you about them today, what I really want to do is tell you about the different types of persistence that we hit, different levels of abstraction, and the problems that we had with them. Because I think it's more interesting to hear sort of the faults that we found while creating libraries than it is to just hear what we're doing now. And through that, hopefully you'll learn a lot, and maybe by the end of it, also think that embracing SQL without abstraction is the right way to do it. So to start things off, a little context. I started at Square about 2 years ago, a little over that. And one of the first things that Jake actually sicked me on when I started working there was this idea of persistence. At the time, we were just using Android's bindings. And they leave a lot to be desired, so we were thinking about how we wanted to handle persistence at Square. And this sort of manifested its way in like a few different tenets. And the first of these was RxJava. What we really wanted was a persistence solution that gave us RxJava, because at the time on Cache, we knew that this was sort of where we were headed. And if you look forward, like now to 2 years after that, most of our UI is actually populated by RxJava things, and we use the database a lot, so we wanted everything to come from the database starting in Rx. The second thing was immutability. This is talked about a lot in other talks, and encourage you to look into it if you're not familiar why it's so great, but like just improving testing and determinism, immutability is a great thing to have. Type safety was another big one. This is one of the biggest things that's lacking in the default bindings, along with compiler errors, just pushing things out of runtime exceptions into compilation exceptions. And then the final one was just SQLite features. And at the time, we weren't using SQLite excessively, but we knew it was a powerful tool, and we wanted to take advantage of everything we could do with it, including like joins, inner queries, triggers, all that kind of stuff. So these were sort of the 5 things that when we went into this, we were looking for. And what we were given was the default Android SQLite bindings, which aren't too great. They sort of manifest themselves in a few different classes, the first of which is SQLite Open Helper. And this is a pretty good abstraction. It gives you the hooks that you actually need to deal with creation and updating of your database. And it does a lot of code that you probably don't want to write yourself. The second of which is Cursor. And I'm not going to go over all of them, just some of the major ones, but Cursor is another big one. Again, this one is actually pretty good. The most boilerplate you hit is just getting column indexes based off of string names. But other than that, like it's lazily loading things, which is really great, and it's for the most part immutable. SQLite database, this is where things start to get a little bit rocky. The API tends to be a little inconsistent. So if you look at things like query versus raw query, right, they sort of perform the same thing, but you look at query and it's essentially just doing string building where it's appending all of the parameters that you're giving to query into what you could just pass to raw query. And if anything, it's less verbose because if you're code reading, you don't necessarily know what each of those parameters mean, so it might be harder to use. But there's also things like content values, which are doing a similar thing, right? They're providing this sort of means to create the insert and update statements. All it's doing is using a string builder behind the scenes. And again, it's one of those things where it's not really providing you type safety. All you're doing is passing in strings to it as column names. And it's just appending them all to a string and creating that insert and update on its own. And when you have something like raw query or execute SQL also on SQLite database, it's a little bit confusing why these exist because you could be using just regular SQLite. It would be a little bit more readable, and it's doing the exact same thing where behind the scenes for content values, it's just doing string building. But then what you start to do is read the documentation for things like content provider and content resolver, and it starts to become clear why they made these decisions. Because content resolver and content provider have APIs like query, insert, and update that map pretty much directly to the SQLite database, and you start to realize, okay, maybe SQLite database is actually meant to be an implementation of a content provider or a content resolver. And if you're like, well, why do content values, for example, have getters on them, right? They're not supposed to be like this stateful thing where you can modify the state in them. Well, they probably have getters because if you're writing a content provider that isn't backed by SQLite, you're going to need to get those values out before you can like insert them or update them. So it's a sort of weird thing where content provider and content resolver seem like they're dictating most of the other SQLite APIs, which isn't really the way that you should be doing things. If you're writing things yourself, you should be going through raw query, execute SQL, because it does give you the full SQLite feature set, and it is a little bit more readable. But understandably, because this is sort of the Android language, you're going to be using the provider and content resolver. One thing to note, too, is it's still a really great API, content provider and content resolver. One way to think of it, or how we have thought about it since this, is that it should really be a view into your database. It shouldn't be your way of like using the database, but it should be a way for other applications to access like a limited scope of your database. Similar to a view, right? When you go to a view in your app, it just has a limited scope of the database. So The problem with raw query and execute SQL is that the way that you have to interact with them is strings, which for something simple is pretty easy. But as soon as you start to add, for example, filters, it gets a little bit more complicated where the arguments don't necessarily match up to question marks. You have to do a bit more parsing. And if you're in a soup programmer, you know that user, the table name there, might change. So you should put it out into a string constant so that if you change it, it changes everywhere else. And of course, you do the same thing for name. And what you end up with is this like extremely awful string that's really hard to read, really hard to maintain. It's very resistant to change. And this is sort of it's like the crux of all these persistent solutions that have spawned from it, because everyone wants to reduce how awful this is, which is totally understandable. So if you look at the SQLite bindings and you go back to what we wanted from them and try and map it, see what you actually get out of the default SQLite bindings, you find RxJava is actually not too bad. Content Resolver and Content Provider have this API for Register Content Observer that actually makes RxJava like pretty easy to implement yourself. So I checkmarked it there, but you have to use Content Provider and Content Resolver. Immutability is something that, again, you're implementing yourself, right? It isn't enforcing you to use immutable objects. So you can do auto value or something to get immutability. Type safety and compiler errors are the two big ones that it just doesn't do anything with. Everything is happening at runtime. It's all being interpreted. And then SQLite features is interesting because it's like this XOR with RxJava, where if you want SQLite features, you can't use Content Provider and Content Resolver. But if you want RxJava, then the easiest way to do it is to use those APIs. So I checked it off, even though it's not necessarily true that you can get both at the same time. So what did we do? Well, we did a lot of research because we knew that the default SQLite bindings weren't going to be enough for us, and we needed to see what else we could find in the wild. So we looked into a bunch of different persistence solutions, and I won't talk about any specifically, but I want to point out some of the problems that we saw in them that were like typical to more than one. So the biggest one, the first one we saw, was excessive use of reflection, which isn't great when you're trying to debug things, and it also has like performance hits. So although it wasn't directly against any of like our tenets, it was something that we didn't like seeing in libraries. The second one was forced synchronous APIs. So this is where you have to, say, mutate data on the same thread that you queried it from. Third one would be lack of type safety. Again, pretty self-explanatory, similar to the SQLite bindings. After that, we have underpowered query APIs. And this sort of goes directly with missing SQLite features. So typically, you'd have to deal with, say, a query builder or something like that that wouldn't be featuring like joins, inner queries, some of the things that we wanted out of SQLite. So this was interesting. We didn't really find anything that matched all of the tenets that we wanted, the things that we wanted out of a persistent solution. So what we decided to do was start to make our own. And you might be thinking, okay, so this is where you started to build SQL Brite. Actually, no, we started to build a library called Scaffold. And the whole point of Scaffold was to solve that whole list of problems that we were dealing with, the RxJava immutability, type safety, all of that. And it manifested itself as an annotation processor that was going to look at interfaces that you generated, something like this, and then generate classes that would give you handy helpers for doing all of the other operations you wanted to do. So you don't need to look at this because this API doesn't exist anymore, but it generated this thing called SC user, scaffold user, which would have a bunch of helper things in it. I've included couple of examples here. Something that, again, with Rx, a func1 that will take a cursor and return a list of users, as well as a cursor and just return a single user. So this is just like an example of what was getting generated. A ton of stuff was getting generated, also to like generate content values and perform queries. So you have this table. You also have a database interface. And you can see there we're also including things like an authority. So Scaffold was also creating a content provider for you. It was creating a SQLite open helper for you. It was doing all the queries for you. So it was really like this God database that was trying to do all of the persistence things that you would need. And so that was one part of it where you were defining your schemas, your table and your database schema. The second part of it was the queries, which you may have seen APIs that look like this in the past. We tried to build one ourselves. It's this sample query builder thing. This is a pretty simple one with only one filter. But what we found in cache and what most people find is that typically what you're doing is more complex queries than this. So something that's pretty common in cache is you'll have something like a payment that's associated with a customer, and that customer is associated with a contact you have on your phone. And when you display a payment on the screen, you also want to show, say, a picture for that customer that is associated with that payment. And in order to do that with the table schemas we have to do a complicated join on, say, the customer, as well as the user, which in this case is like a local contact. And so this isn't too bad, but you can start to see how it becomes a little bit less readable. And if you compare it with just exact SQLite, you can see like it's pretty strictly easier to read this one than that one, although not by much. It's understandable to go with something like this because it doesn't look too bad. But what we found was that writing it wasn't too bad. what made it more difficult was making changes. So let's say, for example, that we have a customer for a payment, but we don't have a contact for that customer. We still want to return the payment, so what we have to do is turn it into a left join. So in Scaffold, this became a little confusing because you declared the type of join after the join. You could have made it just a method, say like left join user class, lots of different ways to do it. In SQL, it's pretty readable. So this one isn't too bad, but what if you wanted to do something like this, where you're adding a filter where you only care if the user is null or the username is Logan. So those are the only two types of users that you want to return in it. In SQL, it's really like additive. All you're doing is adding this one extra line below. And if you already knew what the query was doing, then it's pretty easy to tell what the new query is going to do on top of that. Whereas in Scaffold, you pretty much scrap the old filter and you have to include this new one. And unless you're used to reading arithmetic and prefix notation, then this is kind of hard to parse. So this was a big flaw. And probably the biggest flaw that we had in Scaffold was it was just really hard to write queries and especially to change queries over time. But there were a number of other flaws with it. The closed API was a big one. If you notice, all of our annotations were on interfaces, so you didn't really have the ability to create your own class and methods on that class. You had to deal with the class that we were giving you, even though it was immutable, which is what we wanted. The other thing was that it was just too busy as a library. I talked about this briefly at the start, but like you can look at the list of things that it was covering: RxJava, content provider, query builder, SQLite open helper, the mapping, as well as creating content values, putting things in the database. There are a slew of libraries that handle these things separately, not trying to do them all together. And this was kind of a problem for Scaffold. The other big one was that it was prone to bugs. The code inside was really complex. It had to do a lot of reflection in order for the generated code to reference the static code. So there was a lot of bugs in it, and it was hard to debug, which wasn't great as well. And then inner queries and joins. This is sort of tied to Query Builder, that we saw that anytime we had to do inner queries or joins, it suddenly became like infinitely more complex than doing it in SQLite and really hard to read. So if we look at what we wanted again, and we start checking off things for Scaffold, we see it does RxJava, but not really that well. There were like weird APIs, like if you did an insert, we returned an observable of the user that you inserted. It wasn't an intuitive Rx API, although it did have one. It did cover immutability, but again, we had these like closed objects that you couldn't extend yourself. It was generating an immutable one, but maybe you wanted to add things to it and it wasn't easy to extend. And then the other three, type safety, compiler errors, and SQLite features, even though we had the intention of solving them, we didn't really do that. Because even if you look at the Query Builder API, at the end of the day, we're still passing strings to it. They might be references to string constants that are for a column name, but there's nothing stopping you from putting regular strings in there or maybe referencing the wrong column. So things like compiler errors and type safety, you weren't actually getting from this. So after using this for about 6 months, at Square, we sort of decided that this was too big of a flaw, these last two things, and we needed to do something that wasn't Scaffold. We always had the idea that Scaffold was the right direction to go, but we had just missed a few important things like the type safety that we needed to fix. And so before we open sourced anything, or before we actually created something, we needed to address the type safety. And the way that we thought we were going to do this was through classes like int column and string column. So instead of defining string constants, you would create these like column constants, like int column and string column. And then you could pass those to methods, and you could make sure that the other parameter was going to match it, which is okay, but it has this one big flaw, which is dealing with scope. And dealing with any Query Builder API or anything that's like a Java flowable API, it became really difficult to model scope, and I'll show you what I'm talking about here with a sample query. You can see that in the inner query, depending on where you are in the query, you have access to outer scoped variables. And trying to model this in a type system like Java's is actually really difficult. It almost requires that you use a compiler. And so we realized that in order to accomplish type safety, we would have to sacrifice SQLite features. And likewise, if you wanted to have all SQLite features, you would have to sacrifice type safety. So we didn't know what to do. This was kind of like all of the things that we wanted to accomplish with a persistence library seemed like they were impossible at this point. So we had to put away scaffolding, and we decided, okay, this is just not the right way to handle persistence. What we did decide to do is go back to these things that we cared about, and we said, okay, maybe the right way to do this isn't to solve all of them at once. It's to sort of tackle them independently in the best way that we can. Of course, the first one we dealt with was RxJava, because like I said, cache was moving in this direction. We really wanted everything to be sourced from a reactive database. And this is where SQLite was created. If you're not familiar, SQLite is essentially a copy of the SQLite database APIs like query, insert, and update, but using reactive semantics. So instead of query, it's create query, which returns an observable of a cursor, or of a query which you can get a cursor from. And then likewise, insert, update, they do the same thing, but you pass a table name which you're updating with those. And this was one of the interesting things, was that we had to think about what were we going to emit for? Were we going to try and be super precise and only emit for when that thing that you were querying changes? Or were we just going to allow false positives? And we decided that the only way we could do it is allow the false positives, because otherwise you need something like a query builder to know more about the query. And we didn't want to go down that path again, so we just said, okay, we'll just write SQLite, and we'll just get the table name, and then we'll just do emissions based on the table name alone, and then that way we don't have to worry about actually parsing the SQLite. That also meant that we had to pass in a table name, so it's like a little bit of extra code. But in practice, this didn't end up being too much, because when you go to change a query, it's not often that you're actually changing the table it's querying on. So it's not like you had to change this very often. It was just like a little bit of work you had to put in at once. So something interesting about this is that it has like ORM qualities to it, specifically the mapper part, in that when you're getting your query back, typically what you're doing immediately afterwards is mapping it to a user, and afterwards we added these APIs that made it easier with. So we were starting to get into that territory, but we knew we didn't want to cover the R part, the relational part. But something that was sort of nagging at us was the object part. Because we no longer had like an annotation processor or anything to help us with this, we ended up with these like boilerplate written classes. And I just want to show an example. So like the user that I've been talking about before, the file would always begin with all the string constants that you would use in your SQLite, as well as the create table. The next part would be all of the methods that AutoValue would implement for you. After that, you had to have a mapper which knew how to take a cursor and turn it into a user. And then finally, we tried to give some type safety to content values. So what would end up happening is that anytime you wanted to add a new column to this class, you had to add the string constants as well as the create table string constant. Notice that this is like pretty buggy. If you forget to do a comma or something, then you're going to get a runtime exception. Here we would have to add another method. This one's not too bad. In the mapper, if the type is custom, so something that isn't just recognized by SQLite, you would have to do your custom mapping in here. And then finally, you would have to add another type-safe method to the content values. So for any one PR, you were getting per column 4 changes at least. And typically when we were adding multiple columns or even a new table entirely, you would end up with these massive PRs that weren't actually doing that much. They just had so much boilerplate. So this was a problem. The object side of it wasn't that great. The mapping side, at the time of release, looked something like this. We noticed that there was a lot of boilerplate around going through and sort of parsing the users. I just realized I didn't iterate over the cursor. That's okay. But we did turn this into a helper function, so you could easily map to a list, map to a single, and there's also an as-rows function if you want to do a bit more custom behavior. But the object part of it was still nagging at us. SQLite really didn't handle this. Its problem solving was all based on Rx, and when we were creating it, we really only made the compromise of having to pass in that table name and have those false positives. But we didn't want to deal with the object side of it in SQLite, but we knew this was a problem. There was so much boilerplate. And this is where another library, about 6 months after the release of SQLite, started being developed, called Marshall Mappers. And Marshall Mappers' whole purpose was limiting the boilerplate around the content values and the mapper parts of it. So it was limited at aiming boilerplate, and it was implemented as an AutoValue extension, so we were going to use annotations again to try and eliminate that boilerplate. Unfortunately, this didn't even make it into cache. It was a pretty short-lived project, which is sad because it means we didn't get to see this picture, which Jake very nicely supplied. But I can still share with you some of the code because I think it's interesting to see where it failed. So at the beginning of your user, you still need all of these strings, so Marshall Mappers wasn't going to help you at all with that. In the method part of it, this is where the AutoValue processor would actually go through and learn more about your schema. So you had to annotate with these with the string constant for that schema, as well as if you're using a custom type, you had to provide an implementation of a Marshall mapper, which was something that knew how to map from a cursor to your type, as well as go from your type into content values. And unfortunately, this uses reflection, right? Because you're just passing in the dot class. It has to have like an empty constructor. And then it's going to use reflection to do those operations. So again, not great because we don't like using reflection. This part, the mapper, gets reduced to just referencing the generated class. And similarly, the content values part, we just call it Marshall, and again, you just reference it from the generated class. And this is actually a lot better. You can see the entire file now almost fits on one slide, save for a curly brace. So whenever you need to make changes, mainly what you're doing is adding string constants and then adding another method to the auto value, which is fine. In PRs, this is a lot better. But it wasn't quite complete. It was using reflection, which we didn't like. It still has the auto value fourth wall, which I haven't really talked about up until now. It's essentially this concept of when you're using an annotation processor, anytime you're writing code and you want to reference the generated code, you have to do a build step before you can do that, which is a little bit cumbersome, and especially when you're making frequent changes. So say you're adding a column, almost immediately what you're going to want to do after that is make changes to the Marshall where you're creating the content values, and you won't actually be able to use the new method on the Marshall until you run a build step. So the auto value fourth wall was a pretty big problem. And then the final one was that it didn't really have a real direction. We were trying to limit that object code, but it wasn't even doing that successfully, because if you notice, the string stuff was still all at the top, which, if anything, is the worst part of the whole file, because that's where you're getting your runtime exceptions, that's where you're losing your type safety. So this never made it into cache. It was sort of a project that was great for experimenting, and we learned a lot from it, like these three things. And after we had worked on this for a little bit, there came sort of this turning point where we evaluated the things that were wrong with Marshall mappers and made some pretty critical decisions based off of those. The first of which was rethinking why we're using an annotation processor versus an IntelliJ plugin. The reason you might want to use an IntelliJ plugin is because you can skip that fourth wall step. With an IntelliJ plugin, you can automatically generate the code that you want to interact with while you're typing it. So we thought IntelliJ plugin is probably the way that we want to go forward. What's interesting about using an IntelliJ plugin is now you're not limited to Java-C. So you can actually use a language other than Java to describe your schema. And we thought this was interesting. We thought for a little bit that maybe protos were the right way to go, because there's already technology that exists to generate Java from protos. We thought XML might be a good way to deal with it, because Android developers are already familiar with XML. But then we thought, with protos, XML, all these other things, you have to add support for SQLite features, things like foreign keys, things like auto increment. And we thought, instead of doing it that way, what if you reversed the dependency? So what if you went from SQL into Java? The interesting thing about this is that if you think about it, the only thing that SQL needs to provide in order to generate the same Java that we were writing before is just the type. That's the only constraint that you need to add. All of the annotation processors that we were using before, typically you would see a bunch of different annotations on columns. They were sort of tricking the SQLite into using the right keywords, but typically it didn't have full support. Whereas if you go from SQLite, you already have full SQL support, and then all you have to do is add that custom type, and the generated Java is going to be exactly what you wanted from before. So if we look at the same problem from before, what we did with Marshall mappers, and instead of apply it, we can see that the string constants are gone because we already know them from the create table schema. Similarly, the create table statement is just going to be exactly what you gave us. These methods, they can also be eliminated because we can generate based off of that. You know that the calendar type is custom, so all you have to do is add this extra constraint to SQL. Just tell it that there's a custom type for that, and those methods suddenly disappear. And then all you're left with is the same thing that Marshall mappers was generating, the custom mapper and the custom Marshall, for going from a cursor to your type and then going from your type to content values. So this was a lot better. We had managed to get rid of that big part that we didn't like, which was the SQL text. And it was essentially just a better version of what we had with Marshall mappers. It was using even less code to generate these small classes. Maybe the only knock to it is that you have to create this extra Java class in addition to your create table schema. But what we realized by doing this, and this was really interesting, is that in order to generate the custom class, we had to parse the create table statement, which meant that if you had a syntax error or a semantic error in your create table statement, compilation would fail, which is interesting. We didn't get anything like that with Marshall mappers. And what was also interesting on top of that is that the same technology that we were using, this grammar, to parse create table, was perfectly suitable for parsing any of your other SQL statements. So what we could pretty easily do is just add select statements into the same file, run these same parsing mechanisms on it, and get the same compilation errors if you're misspelling select, forgetting a comma, that kind of stuff. And we said, okay, this is pretty interesting. If we go back to what we wanted before, minus the RxJava, because SQL Brite handled it, all of a sudden we're starting to see that some of these are being solved just by writing SQL. The immutability, again, now you have the choice. You can do it with auto value. And it's generating interfaces, not classes, so it doesn't have that closed API problem that Scaffold had. It does have type safety because now it's generating the proper string constants for you based off of your schema. It has compiler errors, again, from parsing, even parsing the queries and execute statements. And then the SQLite features, obviously, since you're just writing full SQLite, you're getting the full feature set. So we were starting to get some of these things that we wanted, although I've sort of lied about one of them, which is type safety. And I'm going to go into that very briefly. Well, actually, I'll go into it because I think it is really important because a lot of scaffolds problems stemmed from this. And SQL Delight, actually the first version of it, had the exact same problem, which is that if you look at just the columns that you're using in your SQL statement, those still aren't being verified. So you could type anything here. The syntax, like the select from where, those are all being verified because they're required by the parser. But the actual identifiers, you could type anything you want. So there wasn't true type safety. But we wanted to add it in, and because we were already parsing the create table statement to generate this type, we knew about the schema for the table. We knew which columns were available to us. So if we did resolution on the select statement, we could actually verify what was there. So again, knowing that to create table statements, we were able to do proper compilation where we looked at your queries and verified that every single column that was being used was available to it in that query. So we can give you no column definitions now, which is pretty awesome. This was the second release of SQL Delight, sort of gave you this type safety. And you'll find everything that I'm sort of talking about now, we didn't have the intention of doing when we created SQL Delight. They just sort of started happening naturally, which to me was like a pretty good sign that we had hit something really interesting. So the second part of it was that now that we were doing this resolution on the queries, we knew a lot of in-depth information inside the query, so at specific points in the query. So things like if you had your cursor at a point where we're expecting a column name, we can perform autocomplete for you and show you which column names are available to you. And what this means is that you can start writing queries a lot faster. You can be a lot more confident writing your queries because you know what you're writing is actually going to compile. And I mean, this is also like find usages, refactoring. So like before, if you were changing a column name somewhere and refactoring it, you couldn't be confident that every single usage of it was going to be updated accordingly. But with this, we could actually do that, and we could actually look at Java references as well. If you were ever referencing it in Java, we could change those. Also, you could do, so in Android, typically if you click on an ID, it will bring you to the XML file instead of in the generated RIDs file. We do something similar there. So adding all of these IDE features came in the next release of SQL Delight and suddenly made it a lot easier to write SQL. The fourth thing that happened was sort of this realization that we were creating this anti-pattern or encouraging this anti-pattern in SQL where you're constantly select starring. So we were generating this mapper for you, but it only knew how to go from a cursor to your type, the full table type. So you had to do a select star in order to use the mapper. If you did anything else, then you would have to go through the cursor API again. And this is an anti-pattern because SQL becomes really powerful once you start doing like subsets of your actual data set. The efficiency time goes way up. So we really wanted to encourage this, and we did this by generating a mapper per query instead of per table. And this had a really interesting side effect because what we found is that in our views, when we were populating a view with data, typically what we would end up doing is only querying the stuff that was going to populate a view. So say if we were displaying a list of users and we only cared about the name and the photo URL, those are the only two things we would select and then use that interface, which was type safe, to populate the view. And what this did was give us a view model, essentially. If you're familiar with the model view model architecture, suddenly the query became like a view model. And we would have a query that was specific to a particular view, which, if anything, is actually really similar to XML files, where you're creating this XML file that directly relates to a single view. And we were doing something similar in these database files, which, again, we thought was really interesting and started making writing code a lot easier. So there's some other benefits that we found to just writing SQLite in general. And these are things that, after having used it, I would tell people is a good reason to use it. But when I was creating it, I didn't think of any of these. So one of the first ones is just the fact that you're using a shared language. And I don't mean that it's cross-platform. Even though it is, you can like use it on iOS or something. What I mean is that if you run into a problem writing a query, you can turn to your server developers and ask them about it. And I've done this in the past where I was struggling with some join or something like that, and I could ask one of the senior server guys, and they were able to help me out with it. The second one was just the confidence writing SQL. So this is big because when you're just doing select star from table, and then mapping that to like a list of users or something. Typically what I would end up doing, and I've seen other code bases do, is you would get the full list of users and then you would do your filters or your sorts or something else in Java where you were confident with the compiler. But now that you're confident in the compiler with SQL, you can start to move those filters into SQL where it's actually going to run more efficiently and you're going to save a lot of time. The third thing was the tight coupling with views. So the idea that now these queries were almost like a XML file in the Android world for a specific view, except they were providing you this view model that you'd use to populate the view. And then the final thing was just easier code review. I touched on this a little bit in the scaffold part where I was looking at that query. Anything like these projections, it becomes really simple to understand if you're just adding a new column to the projection, what's going to happen, or adding a new filter. So it became a lot easier to code review, and any sort of data logic became a lot easier to like make pull requests and get changes in. So that's up to now. Those are like the organic changes that have happened within SQL Delight, but we do have a little bit of foresight into what's going to come next. And the first big one is replacing those filters at the bottom with the proper bind args. This is actually the biggest problem in type safety that's still left, because you do still have to pass that string array to the raw query statement, and you have to create that yourself. So what we're doing, and this release will probably come in the next week or two, is we'll generate methods for you that take only the proper type. And what's interesting is because we're a compiler, we also know when you're expecting a set, so we can do things like generate a method that takes only a string array, whereas traditionally you would have to create question marks yourself for the size of the string array, and then create that SQL. And then we can also do things that you would expect from like string.format, where you can reuse the same argument over and over again. So this is going to provide like that sort of final layer of type safety that we feel like you need when you're writing SQLite. But there's other things that we have in mind. Migration verification is something that we could do. Again, we know your alter table statements because they're in SQ files. So we can look at those, compare them with your current schema if they're used against, say, some old database, and verify that the schemas are the same at the end. We can also do things like add testing support. So you could imagine a preview window similar to the XML one where you might see query results. Or you could give us input and output data and we could generate JUnit tests for you that actually verify that your queries are returning what you expect. And the final one is probably Kotlin support. This one is actually really exciting because Kotlin has a lot of features, especially around data classes. Right now, we're almost enforcing you to use auto value because otherwise you have to create these very large classes. But with Kotlin, we might be able to take advantage of some really cool features and make those generated classes even smaller and even easier to work with. So those are some interesting things we're working on. But what I want to go back to finish this off is the problem that I mentioned when we were making SQLite. Because when I was talking about it, I said that we had to make a few compromises when we were making SQLite, that we had to do a bunch of false positives, and then also you had to supply the table name. But now that we're compiling the actual query, we know the table names for you. So we can pass that or communicate that to SQLite, and you're no longer going to have to provide the table names that are involved in a query. But even beyond that, we know your filters. So we know that you're checking, say, the primary key or some other part of it, and we can statically, at compile time, figure out like which insert statements are going to affect this select statement. Is it dependent on some variables? We can know all that statically, whereas before we were thinking in SQLite that we would have to do this like runtime type thing through a query builder. We would have to check args to see if it would actually update the query that you had created. But now, if we do this statically, we could potentially have this like compilation time generated code that could decrease the number of false positives, for the most part, to 0. Obviously, there are going to be cases where you can't because there are like aggregate functions in SQLite and things like that that make it really complicated. But the idea of like reducing that as much as we can is something that's possible now because we're compiling SQL. And really, all of this is possible because there was that turning point where we thought maybe writing SQL is the right way to do things. And instead of trying to come up with these abstractions on SQL, we just started to write tools to make writing SQL easier. And all of these tools have sort of organically grown, but like it started out as a very modest idea of just generating that object class for you. But now that we've started writing the tools for it, we have all of this support and all of this capability that has just come afterwards, and there's just going to be more to come. So it's really exciting. And that's it. If you want to contact me, that's how you can do it. If you want to ask questions, feel free to come up to me or talk to me on any of these resources. That's it. Thanks a lot for listening.